welcome back to my channel. As you guys know, in my previous video I have made a robotic arm, and now we're going to mix the robotic arm with a conveyor using Arduino in this video. So let's jump right into it. Now let's look at what is included in our project. This is my robotic arm, which I have made in the previous video, as I have said it in the introduction. And if you don't know how I made this robotic arm, you can look at my previous video or find the link below in the description. Guys, this is the microcontroller Arduino I have used for this project. We can use this Arduino for lots of complicated projects like this one. I have used this because there are lots of more pins than microbit. This is Arduino R3, and there are lots of different types of Arduino and microcontrollers that you can use. I have used Arduino Uno R3. So guys, this is the programmable port, and this is the wire for the programming. This is the programming cable. You can plug this in. So this part you plug it into that one, and this part you plug it into your laptop or computer. So this is an external power supply for Arduino. This chip is the heart of Arduino and it's called microcontroller chip. So when I download any program into the port or from the cable port, it will go and sit in this microcontroller chip. Guys, these are the signal pins for our Arduino. So do you see the squiggly line near the number? This squiggly line means it is a PWM port. PWM port is called pulse width modulation port, and it is basically used for servo motors. So coming over here, we have these analog input pins. Analog input pins are basically used for like potentiometer and stuff like that. And the power pins over here are basically the power pins. Ground, 5-volt pins, and 3.3 volt pins. So these are all the ports. Guys, this is our conveyor. If you don't know what a conveyor is, it is a mechanism which has one object from one place and it moves to another place. So it can be picked by a robot or a robotic arm. For the hardware of the conveyor, you will need 2 tissue rolls so there's one here and one here. 1 conveyor belt, so I just used a gift wrapper. Cardboards for support and a base of cardboard. You can just wrap a gift on the base to make it look good. 1 motor to spin the conveyor, obviously. A stick to go through the roller so it can spin. Some wires and some jumper wires. Batteries and a battery pack. A switch. And the last thing you will need is a relay. You might be wondering why we need this relay. We need this relay because we can't send direct current from Arduino to the motor because it doesn't get sufficient power. So that's why we use a relay. And in the relay, when Arduino gives power to the relay, there is a coil inside which will get magnetized and pull 2 bars together, which will complete the circuit and give sufficient power to the motor, and then the motor will run. Guys, now there's a big problem. How is the robot going to know that there is something in front of it? That's why we're using an ultrasonic sensor. Ultrasonic sensor is basically a contactless sensor which uses sound waves at a frequency of 40 kilohertz. We cannot hear the sound waves because we can only hear the sound waves which are under 20 kilohertz. Ultrasonic sensor has two main components, a transmitter and a receiver. I will show you how they work on a piece of paper with a diagram. So as I said, the ultrasonic sensor has two main components, a transmitter over here and a receiver over here. So I'll just write trans and receive. So here the transmitter sends sound waves at a frequency of 40 kilohertz. So if there was an object in front of it like this, any object, it will bounce off and return to the receiver over here. That's how the ultrasonic sensor works. So now we need to see how the ultrasonic sensor finds its distance. So it does a calculation like this. Distance equal to time multiplied by speed divided by 2. It is divided by 2 because it takes one time to go and the other time to come back. So 1 and 2. So that's all for our ultrasonic sensor. Coming to the pins of ultrasonic sensor, there is one pin VCC. It is basically a positive pin. And on the other end, it's ground. Ground is basically the negative pin. And in between them, you can see there is a trigger pin, which is the transmitter and sends the sound waves. And the other one is called echo, which is the receiver and receives the sound waves. So these are the pins of ultrasonic sensor. We finished our hardware and now let's move on to the software. So guys, now let's head to our Arduino IDE app, which we are going to program in. And I will also put a link below in the description of this app. So first I will show you the new page of this app. So the version of this app is Arduino 1.8.112. So this is how our default already set up program will look like. So void setup is basically you define your pins in the setup, and in void loop is your main program. So now I will head to my program which I've already done. So at the very start we have to include a library, include servo.h. So you add this library, because if you don't add this library your servo won't work, because it says servo.h. Because you're using servo motors for our robot, we have to add this library. So in this, constants won't change. We just define the speed of our servos and some variables and pins. And over here we all define the variables again. So this is the setup, void setup, where we define our monitors, serial monitor. So serial monitor is basically a monitor where you can see your see what's going on in your program. Now this void loop is the main loop, as I already said, and here it says mills. I used mills because mills helps me to do one thing and another thing at the same time. And now, so these are called functions, which are going to be called from the void loop, the program underneath over here, which are going to be called from there and are going to be acted in a sequence. So first our robot goes down, its arm goes down, then the gripper closes. So we have to close the gripper to pick something up. Then the arm goes up to turn right. So the base will turn right, and then the arm will go down again. So the gripper will open and then leave the object into some kind of container. Then the arm will go up and it will go back to its home position, base left. I will only explain you one part of the code, and then you can find the rest in the link in the description below. So this is the code for conveyor and sensor. I just named it white conveyor. So this trig pin is basically the transceiver pin, and then over here we have to trigger pin. Basically we define the pin, and then there's an echo pin, which is our receiver pin. I've already talked about the ultrasonic sensor, so you might also know that. And this is the main part of ultrasonic sensor to define the distance. If distance less than or equal to 14, the motor pin of conveyor will stop. So this is the code for our conveyor with ultrasonic sensor. Now the first thing it will do is arm down, right? Because the arm down and the gripper close. So I will only talk about this one, and then you can find the link again in the description below. So arm.write 1375. So arm.write is the command from the library we have included at the very start called servo.h, and the number over here is the speed of the servo motor. If it is under 1500, it will be clockwise, and if it is over 1500, it will be anti-clockwise. So arm.write, so we use this again, and 1450 means it will stop. So it goes same thing for gripper close, gripper open, base right and base left. And you can find the code in the link in the description below as well. So this is the code for our project. Thank you guys for watching my videos. Please make sure you like, subscribe and hit the bell icon for more amazing videos. Stay safe, and I'll see you guys in the next video.